So introduction to networking and content delivery services in AWS, including Amazon Virtual Private Cloud or VPC, configuring security groups and network access control list or NACL, AWS Private Virtual Private Network or VPN solutions, or AWS Direct Connect. So let's dive into the world of VPCs or virtual private clouds within the AWS infrastructure. A VPC is essentially your own isolated segment of the AWS cloud, providing a secure environment for deploying resources like compute, storage, databases, and networks infrastructure. So when you create a VPC, it's completely isolated, accessible only by your own AWS account. Each AWS account can have up to 5 VPCs per region, and creating one is as simple as defining a name and the IP address range using a CIDR block. In summary, a VPC is a secure space within the AWS public cloud, allowing you to provision and deploy resources safely. Stay tuned as we delve deeper into VPC architecture and discuss subnets and segmentation across multiple availability zones for resiliency and high availability. So let's try to understand subnets in AWS VPC. So subnets reside inside your VPC, allowing you to segment your VPC infrastructure into multiple different networks. These can create better resource management, isolate certain resources, or enhance high availability and resiliency within your infrastructure. So public subnets are accessible from outside the VPC, while private subnets are considered private and inaccessible by default from the internet. To make a subnet public, you need to add an internet gateway and configure the route table. This allows the subnet to access the internet. To ensure high availability and resilience, it's best to deploy resources across multiple availability zones. This way, if one zone experiences a failure, your services will remain up and running. By adding additional subnets and replicating resources, you can ensure that at least one subnet in each layer of your infrastructure remains operational. Now that we have covered subnets, let's move on to some security features. Managing security in AWS Virtual Private Cloud. So security is a crucial in any AWS deployment, and it's no different when it comes to your VPC. One key component is NACLs, or Network Access Control List. These access virtual network level firewall for each subnet, controlling both inbound and outbound traffic. By configuring NACLs, you can ensure that only the desired traffic is allowed in and out of your subnet. So for example, in a public subnet with web servers, you can set up inbound NACL rules to allow HTTP and HTTPS traffic while denying all other traffic. These ensures that only the necessary traffic is permitted. Similarly, outbound NACL rules restrict traffic based on its destination. They allow specific traffic to exit the subnet while denying all other traffic. So remember, NACLs are stateless, meaning response traffic must be explicitly allowed. They are a powerful tool for controlling traffic in and out for your subnets. Security groups and network access control lists, NACLs. These are crucial for filtering traffic and ensuring the security of your network. Security groups operates at the instance level, allowing you to control traffic to and from specific instances. They are more specific and flexible compared to NACLs, making them ideal for controlling access to databases and other resources. On the other hand, NACLs work at the subnet level, providing a broader control over traffic within the subnets. They are essential for filtering traffic at the network layer. Both NACLs and security groups work together to provide comprehensive security. NACLs control traffic at the subnet level, while security groups manage traffic at the instance level, ensuring a multi layered approach to network security. By understanding the roles of NACLs and security groups, you can effectively control and secure the flow of traffic within your network. So let's try to understand the NAT gateway in AWS VPC. In an AWS VPC, a NAT gateway allows instances within a private subnet to access the internet while blocking all incoming initiations from the internet. This ensures the security of the private subnet and helps in maintaining the security of EC2 instances. The NAT gateway sits within the public subnet, has a public IP address, and is managed by AWS. It's easy to set up and configure, and AWS will manage all other configurations. If you have multiple public subnets in different availability zones, you will need to set up another NAT gateway within each subnet. In summary, a NAT gateway is a crucial component in AWS VPC, providing secure internet access to private subnets while maintaining the security of EC2 instances. So let's dive into the world of VPN connections, also known as virtual private networks. A virtual private network is a secure way of connecting two remote networks across the internet. In the context of AWS and VPC, it's a powerful tool for enabling secure communications between resources in a private subnet and on-premises data centers. To set up a VPN, you will need to create a virtual gateway in your VPC and a customer gateway in your data center. Then you will initiate a tunnel between the two endpoints and configure the route table associated with the private subnet. Now let's talk about Direct Connect. Unlike VPN, Direct Connect doesn't use the internet. It's a method of connecting your remote location directly to AWS environment using a private infrastructure. So whether it's setting up a secure VPN connection or exploring the benefits of Direct Connect, there are multiple options for connecting your own premises data center to your AWS environment. So let's try to understand AWS Direct Connect. This is a method of connecting your remote location like a data center or remote office to your AWS environment. It's different from a VPC connection because it doesn't use a public internet. Instead, it uses private infrastructure to connect directly to your VPC. With Direct Connect, there is a middle entity, usually an AWS partner or customer, that holds the infrastructure. These includes a customer side and an AWS side, both within a facility owned and managed by a partner of AWS. The connection is made to a defined AWS region, not just a VPC, allowing access to public and private resources. You can configure private and public virtual interfaces on your router. The private interface connects to your VPC, while the public interface allows access to public AWS resources. These all happens without traversing the public internet using dedicated and isolated infrastructure. Direct Connect offers a private connection with speeds from 1 to 10 gigabytes per second, making it a reliable and high speed option for connecting your remote location to your AWS environment. So that's a high level overview of AWS Direct Connect. Stay tuned for more insights on VPC peering and the transit gateway. Understanding VPC pairing in AWS. VPC pairing allows you to connect two VPCs together, enabling communication between resources in each VPC, whether they are in the same region or different regions. It's important to note that VPC pairing is one-to-one connection only, meaning each VPC can only be directly connected to one other VPC. With setting up VPC pairing, ensure that the IP addressing schemas of the VPCs do not overlap, as these would prevent the pairing connection. To initiate a pairing connection, the owner of one PPC sends a pairing request to the owner of the other PPC. Once accepted, both VPCs update their routing tables to allow traffic to flow between them. And that's a brief overview of VPC pairing in AWS. Stay tuned for more insights. So let's jump into the overview of AWS Transit Gateway. It's a central hub that simplifies network connectivity, allowing all your VPCs and remote locations to communicate with each other easily. With AWS Transit Gateway, you can connect all your VPCs and remote locations through a central hub, reducing the complexity of managing multiple connections. This centralization allows for easier monitoring of network traffic and connectivity through a single dashboard. In summary, AWS Transit Gateway streamlines your network infrastructure, making it easier for VPCs and remote locations to communicate. So say goodbye to hassle of managing numerous VPC pairing connections and embrace the simplicity of AWS Transit Gateway. So let's dive into the world of domain naming system and how Route 53 provides secure and reliable routing of request. So what is DNS? DNS or domain name system is like the phone book of the internet, translating domain names to IP addresses. It's a crucial part of how the internet functions. Route 53 is Amazon's highly available and scalable domain name system, offering secure and reliable routing of requests. It's managed through a global network of authoritative DNS servers, reducing latency and providing secure routing. Route 53 includes components like hosted zones, supported domains, resource record types, and routing policies, each playing a vital role in managing and routing traffic effectively. With its robust features and global network, Amazon Route 53 is a powerful tool for managing DNS and routing traffic. So let's try to explore how Amazon CloudFront works and its key features. Amazon CloudFront is a content delivery network service provided by AWS. It's designed to speed up the distribution of your static and dynamic content through a network of edge locations worldwide. When a user requests content, CloudFront routes the request to the closest edge location, reducing latency and delivering the best performance through cached data. CloudFront uses distribution to control which source data it needs to redistribute and to where. It offers two delivery methods: web distribution for static and dynamic content, and RTMP distribution for streaming media. So when configuring your distributions, you will need to enter your origin information, selecting caching behavior options, and define the distribution settings. Once your distribution is configured, you simply enable it for it to be created. These allow end users to access content from their closest edge location, reducing latency and improving performance. And that's a brief overview of Amazon CloudFront. Stay tuned for more insights on AWS services. So let's explore how these AWS Global Accelerator can enhance the speed, reliability, and security of your application. The AWS Global Accelerator efficiently routes UDP and TCP traffic from end user clients to applications, leveraging AWS global infrastructure and specified endpoints. These ensures faster, more reliable connectivity compared to traversing the public internet. To set up the AWS Global Accelerator, follow four key steps: creating the accelerator, setting up a listener, associating it with an endpoint group, and finally registering your endpoints for the application. So let's take a quick look at how to create an AWS Global Accelerator in an AWS Management Console. First, select a name for your accelerator and choose the IP address type. Then add listeners for incoming connection and configure endpoint groups for different regions. With AWS Global Accelerator, you can easily enhance the performance and availability of your application across multiple regions.